So today I'll be doing some problems on probability. So let us begin with some preliminaries. When you toss a coin once, what is the sample space? The sample space contains either a head or a tail. So the exhaustive number of cases, that is total number of possible outcomes, is 2, which we denote by n. Similarly, when we toss two coins, then the sample space is either first show head, second show head, first coin show head, second coin show tail, first coin show tail, second coin show head, or both the coins show tail. So the possible number of outcomes is 4, which is 2 into 2. That is 2 outcomes from the first coin and 2 outcomes from the second coin. Similarly, when we toss one dice, n is equal to 6. But when we toss two dice, n is equal to 6 outcomes from the first dice and 6 outcomes from the second dice. And we multiply both and we get the total number of cases as 36. So let us see what are these 36 cases. S is equal to, see, S is equal to either the first dice show 1, second dice show 1, first dice show 1, second dice show 2, first dice show 1, second dice show 3, first shows 1, second shows 4, first dice shows 1, second dice shows 5, first dice shows 1, second shows 6. This was first dice shows 2, and for 2 there are again 6 cases. For the first dice showing 3 there are 6 cases. For each of 1, 2, 3, 4, 5, 6 on the first dice, there are 6 others on the second dice. Hence, the total number of cases is 6 from the first into 6 from the second. That is 36. Now let us start some problem. 2 dice are tossed simultaneously. Find the probability that both the dice show the same numbers. The first dice shows a 6. So, two dice are thrown together. So the total number of exhaustive cases will be, just now I showed you, 6 from the first dice into 6 from the second dice. That is 36. The simple space is this, which I have shown just in the earlier page. Now, the first one. Let us denote this event by A. A is the event that both the dice show the same numbers. So, what will be the set A? What are the values A can take? A can take these values 1, 1. Means both are showing same number. So both may show 1, 1. Both may show 2, 2. Both may show 3, 3. Both may show 4 and 4. Both may show 5 and 5. Both the dice may show 6 and 6. So A will be the set of all these numbers. So how many cases are there? 1, 2, 3, 4, 5, 6. So M is equal to 6. Therefore, probability of A is M by N, so 6 by 36 equal to 1 by 6. Similarly, let us see the second one. Let us denote A. The event is the first dice show a 6. So first die will show a 6. So what are the cases values A can take? A can take these values. First is showing 6, second showing 1, first showing 6, second showing 2, first showing 6, second showing 3, and this whole green highlighted number. So we write A as 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So M is equal to 6. Thus probability equal to 6 by 36, 1 by 6. Okay, now come to the second problem. 2 dice are thrown simultaneously. Find the probability that the total of the numbers on the dice is 8. and the total numbers on the dice is greater than 8. So again, since 2 dice are thrown, the total number will be n is equal to 36. Now I am not again writing the sample space. I hope all of you have understood what will be the values, possible values of the sample space. So let us define event A as total of the number on the dice is 8. So let us find what will be the values which A can take. A can be first shows 2, second dice shows 6. So the total is 8 here. Similarly, the first dice shows 3, second shows 5. Total is 8. First shows 4, second shows 4. Total is 8. First shows 5, second shows 3. Total is 8. First shows 6, second shows 2. Total is 8. Okay. So only these 5 cases will be there for A. So M equal to 5 and probability of A equal to 5 by 36. Similarly, let us define the event A for the second one as A is the event that total of the numbers on the dice is greater than 8. Now it is greater than 8. So I will consider all the sum of all those numbers which are greater than 8. So it will start from 9. The total sum will start from 9. So A can take these values. First shows 3, second shows 6. So the total is 6 plus 3, 9, that is greater than 8. First shows 4, second shows 5. So the total here is also 9, which is greater than 8. First shows 4, second shows 6, total is 10, greater than 8. First shows 5, second shows 4, total is 9, greater than 8. First shows 5, second dice shows 5, total is 10, greater than 8. First shows 5, second shows 6, total is 11, which is greater than 8. Then 6, 3, this combination also is greater than 8. 6, 4, 10, greater than 8. 6, 5, 11, greater than 8. 6, 6, 12, greater than 8. So these are the possible values for A. That is the favorable total number of favorable outcomes is M equal to 10. There are 10 cases. So probability of A is 10 by 36, that is 5 by 18. Now let us see the next question. Among the digits 1, 2, 3, 4, 5, at first a number is chosen and then a second selection is made from the remaining 4 digits. That means first we have selected a number from these 5 digits. Then since we have selected one digit, one number has gone. Now from the remaining 4 digits, the second selection is made. So find the probability that an odd digit is selected the first time, the second time, and both times. So let us see the sample space first. Now the first selection is made from 5 digits and the second selection is made on 4 digits. So the total number of exhaustive cases will be n equal to 5 from the first into 4 from the second selection, that is total is 20. Let us see what are these numbers. 1, first selection 1, then 1 is gone, so second selection will be for each of these 4 digits. 1, 2, first selection gives 1 and second gives 3, 1, 4, 1, 5, then 2, 1, 2, 3, 2, 4, 2, 5, and so on. So this will be the 20 possible outcomes. So n is equal to 20. Okay. Now let us define event A as selecting odd digit the first time. So what are the odd digits out of this 5 digit? 1, 2, 3, 4, 5. The odd ones are 1, 3 and 5. So if odd digit is to be selected the first time, then we will have these combinations. See, in these combinations, all the first digits are odd. Here 1, here 3, here 5. So A will take all these values so that M is equal to 12 and probability of A is 3 by 5. Similarly, let us see the second one. An odd digit is selected the second time. So when it will be selected the second time, then we will have the following combination. Here you see all the second digits are odd. So m is equal to 12 and probability of A is 3 by 5. For the number 3, let us define event A as an odd digit is selected both times. So if an odd digit is selected both times, we will have the following combination. First is showing 1, 3, 1, 5, 3, 1, 3, 5, 5, 1, 5, 3, and nothing more than this. So the total number of favorable cases is m equal to 6. So the required probability is 6 by 20, that is 3 by 10. I hope you have understood these three sums. Practice, complete your sum and submit it to me.